All right, guys. So we're going to kind of continue our stuff from yesterday. We're going to look at some tables and see what we can do with them with our calculator. So it says the table below shows the life expectancy of people born in the U.S. between 1900 and 1990. What we're going to do is use our calculator and these data points and see if we can find some information. So what we need to do first, guys, is we need to put this information in our calculator just like we did last week by putting our X values in L1 and our Y values in L2. So go to Stat and Edit. Remember, L1's X, L2 is Y. I'm going to give you just a second to throw those in. Once you do that, we need to make sure that our diagnostics are on, and we need to go to Stat again, go right to Calc, and then we want linear regression. So go ahead and throw those in there, and we'll put those down at the bottom. So we need to pause for a second. Now once we do it, we do our lin reg, we get the y equals ax plus b. Remember, if you're not getting r squared or r, go to second 0 and turn your diagnostics on. Make sure once you hit enter on diagnostics on, you hit enter again and you see done. But once you do that, it should give us several values. It'll say y equals ax plus b, and it gives us an a that is 0.325818118. If we look down at B, it gives us negative 570.5363636. It gives us an R squared of 0.966350149. But remember, we don't care about this one. We're going to write disregard. And then the R it gives us is 0.983031117. So hopefully you got those same numbers. It's a lot of decimal points, but let's go to the next page and see what we can do with that. So the first question it asks is this data linear? Well, it's not. And you should know because R is not equal to -1 or 1. It was a really long decimal, looks like 0.983. That is not -1 or 1, so it is not linear. It asks us, so what's the best line of best fit? Well, we can round to the nearest 10,000th, which is 4 decimal places, and we can plug in our information. So we had y equals, and then we plug in our a rounded to the 4 decimal places, 0.3258x, and remember that a is the same as our slope, or m. And then we had for our b, negative 570, around to 4 decimal places, 5363. So we have an equation there that'll work. It's not linear because, of course, our points aren't lined up in a straight line. Now what we want to do next is look at them in the graph. Now you've already got these entered into L1 and L2, so there's a few buttons we can push to make it pop up on our graph as well. To look at it first, we need to go to second stat plot. That's the button above the y equals. Once you're in there, you're going to select plot 1. You're going to push enter. And you want to make sure it's turned on. So highlight on and push enter. You're going to go down to type. You're going to choose the first one and push enter. We want the X list to be our L1s because we put our X's in L1. So do that and push enter. Then go down to your Y list and choose L2. You'll have to shift over 1 from L1 and then press enter again. And then we want to go down to the mark section, choose the first one, and then we push enter. Next, we want to push zoom 9. Then we will hit second quit. Second quit is above mode. If we scroll down a little bit further, now it says, now using this equation of the line of best fit, find the following. This is just going to basically ask us to plug in some numbers for X and see what the average life expectancy was in those certain years. You should be able to kind of look at the graph now. So if you can look on there, you can kind of see the estimations of our answers. But we have an equation that sort of fits, best fits, so we're going to plug our information in there. The first one says, what's the life expectancy of a person born in 1942? It says round to the nearest whole number. So we're going to plug in whole numbers when we get our answers. So we have our equation, y equals 0.3258, and it's times x. Well, they gave us an x of 1942. And then we subtract our 570.5363. So that's just straight in your calculator, guys. And if we get that and we round, you should get that the average life expectancy was 62 years. So it's really not a tough one. Why don't you try the next two before me if you want to make sure you've got this. All it is plugging in a couple more numbers. So I'm going to go ahead and plug those in. Y equals 0.3258, our X value 1986, minus our B 570.5363. And again, we're just plugging that into our calculator. Be careful, that's a lot of decimals. Don't miss your decimal sign. It actually gives us about 76.5. We're going to round that to 77 years. So the information was only through 1990, and now we're going to use it kind of as a prediction of what it might be in 2000. So we plug that in for our X. Y equals 0.3258, times 2000, our X value, minus 570.5363. And again, you just plug that into your calculator, and you should get 81 years. So not too tough, guys. Just make sure you use your calculator right. And, of course, we want to be careful when we're pushing all our buttons. If you have any questions over that, you need to come ask. And now the last problem. Let me get out of this, sorry. Our last problem on this one says, what year was the person born and whose life expectancy was 67 years? And it says round to the nearest whole number. Now, this isn't giving us our X values. It's giving us a Y value. So we're going to plug in 67 for Y. And then we're going to have to solve for X. We got 0.3258X minus 570.5363. So, and when we solve for X, the first thing we need to do is move our numbers to the other side. So I'm going to add the 570.5363 to both sides. Sorry, my stylus isn't working. 5363. So we do the arithmetic there. You should get, and I'm going to come up here, you should get 637.5363 equals 0.3258 X. All we did was moved our number to the other side. Now we just have some multiplication undo on the right side, and we should be finished. I'm going to divide both sides by what's attached to X. 0.3258. I put this in my calculator, and you end up getting X equals, and if we round that, you get 1957. So what that means is that in 1957, you had a life expectancy of 67 years. All right, guys, so let's go ahead and go to the next problem. All right, so this last one says, the table shows the hours of TV watched by 10 students and their scores on a math quiz. So it's going to ask us a few general questions first, like what's the independent variable? Remember, our independent variables are X values. In this case, I'm going to write X there, so remember it looks like it's the hours that you watch TV. Our dependent variable is the Y values, which in this case is the score on the quiz. So that's not too bad. Now, we need to answer the next couple of questions. We're going to have to use our calculators again. It wants, is the data linear, and it wants the equation of a line of best fit. So what we're going to need to do is go into our calculator into stat. You need to plug hours into L1, score into L2. Once you do that, hit second or hit stat and go to the right in calc, and then you're going to go down to number 4. So go ahead and do that real quick. Make sure you can do that. When I threw it into mine, I got that the data was not linear because I did not get R to equal -1 or 1. The equation of best fit I got was Y equals -1.3546. I went ahead and rounded to 4 decimal places just like we did on the other one. X plus 87.1569. Hopefully you got those same numbers. So that gives us something. Remember, this is based out of the equation Y equals mx plus b. So it asks us for our slope in the next one, where our slope is the negative 1.3546, the number in front of x. The y-intercept is the b, that's the 87.1569. So those aren't too tough questions. The next one can be a little tricky though. It asks, what does the y-intercept mean? Well, if we're going, the y-intercept is where it crosses the y-axis, okay? That's when x equals 0. So we want to think about what that means. If I have 0 for x, that means I watched 0 hours of TV. So that means that the y-intercept is like the average score if no TV is watched. So we're going to write the average score if no TV is watched. Oops, sorry, I have that little thing in the way. Watched. So the big thing to remember there is when you have the y-intercept, that means that x equaled 0. And that meant that the hours equaled 0. I'd watched no TV. Now, the last couple of questions just kind of want you to plug some stuff in. If we look at them, it says, if a student watched 20 hours of TV, what would be the best prediction for their quiz score? Well, if they're giving us hours, that's our x value. So what they're saying is let's plug in 20 or x. So I'm going to leave that one to you. The last one says, if a student made a 70 on their quiz, what's the best prediction of how many hours of TV they did watch? Well, that's not giving us x, that's giving us a score. So they're saying sub in y equals 70. Now, you can do all the work yourself, guys. We've seen it several times. If you did the first one right, you should have gotten, if they watched 20 hours, they should make a 60 on the quiz. If you did the next one right, you would put 70 in for y and solve for x. You should have got x equaled 13 hours. So hopefully that helps out, guys. If you have any questions, again, come and ask me in class.